So today we are going to learn about surds. Before we learn about surds, we need to know the different types of numbers that we have. If I'm talking about different types of numbers, so we basically have two types of numbers. One number is called the rational number, another number is called the irrational number. Rational numbers are basically your integers, your fractions, your terminating decimals, your recurring decimals. But when I talk about irrational numbers are nothing but they are your thirds. We will talk about thirds a bit later after we distinguish between a rational number and an irrational number. So when I talk about rational number, I say integers are my rational number. What is an integer? An integer is basically a whole number. So whether you take any positive number like 5, 13, 412, it is an integer. A negative number is also an integer. In fact, even 0 is an integer. Remember, all integers are rational numbers. When I talk about fractions, what is a fraction? A fraction is a part of a whole number. So I have one whole number 3 over another whole number 8, or I would say 3 divided by 8. It becomes a fraction, and this is also a rational number. So when I sum up, a rational number would be an integer, which is a whole number, whether positive or negative or 0. A fraction, which is also a whole number, divided by another whole number. And when you divide it, you get the answer in decimals. And if this decimals is up to a finite number, okay, is up to a finite number, or if this decimal is recurring in nature, this would also become a rational number. Let's take it with an example. Let's take this with an example. If I have 3 and I divide it by 8, so 3 divided by 8 is going to give me 0.375, which is a decimal. And a decimal, this is a decimal that is finite in number and it is not recurring. That means it stops somewhere. So it would become a rational number. So if I say I have a pizza and I divide it into 8 parts, so it would be divided by 8. If somebody eats 3 parts of it and I want to write the fraction of the eaten parts, so 3 by 8 becomes a fraction of the eaten part, and the fraction of the pizza that is remaining with us would be 5 by 8. Now, say this is a fraction of two whole numbers. If you divide 3 by 8, you're going to get 0.375, which is a rational number because these decimals are terminating, they are ending somewhere. But when I say 5 divided by 8, it is 0.625. You can see very clearly over here. 0.625. Again, this is a decimal that is terminating in nature. If you convert these decimals into fraction, this will again become a rational number. So fraction is a part of whole numbers. So up till now, we have done rational numbers. What is rational numbers? Rational numbers are something that is your integers. Your integers are your rational numbers. What is integer? Whole numbers, positive, negative, or zero. Fractions are your rational numbers. And these fractions, when you convert it into decimal, it either should be a terminating decimal or it should be a recurring decimal. When I say it should be a terminating decimal, that means zero point 0.5 or 0.625. It is a terminating decimal. This is a rational number. If I talk about a recurring decimal, so if you see 0.6666666, that means the 6 is going on forever. It is a recurring decimal. So a way to write it is I'll write 0.6 and above the 6 I will put a point denoting that this 6 is recurring n number of times. If I have a decimal that is 0.123, that means this 123 is recurring. Another way to write it is I will write it as 0.123 and I will put a dot above 1 and above 3, denoting that this is recurring. If I have a decimal which is 0.4781, 4781, how will I write it? It will be 0.4781 and the dot will be above 4 and 1, denoting that this is the first whole number that is recurring and this is the last number that is recurring. If I have to write 0.5 in the form of fraction, how will I write it? 0.5, this is nothing but it is half. I press SG. If I want to write 0.625 as a fraction, I will press 0.625 SD. So it's nothing but 5/8. This is a terminating decimal. Any terminating decimal or a recurring decimal is a rational number. Okay. So can you give me what are rational numbers? What are rational numbers? Rational numbers are nothing but they are your integers, which is your whole number. They are your fractions. They are your terminating decimals. And they are your recurring decimals. Okay. But when I talk about irrational number, what is an irrational number? An irrational number is nothing but your surds. What is surds? A way to denote your irrational number is that it is a square root. Square root of a number that is non-square. So do you know what are square numbers? Do you know what are square numbers? So if I talk about square numbers, if you don't know what are square numbers, it is very good that you memorize square numbers. So what are square numbers? One square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81 and 10 square is 100. So these are square numbers. So what is surds? When I talk about surds, it is square root of a non-square number. So anything that is over here, if a square root of that number is there, like the square root of 9, 9 is a square number. So square root of 9 is 3, and 3 becomes a rational number because it is an integer. So when I talk about surds, surds is nothing but it is a square root of an irrational number. Okay? When I talk about pi, if you see pi, if the value of pi is 3.1415926555359 dot. That means this number, the decimals are continuing forever and they don't repeat. There is no pattern of its repetition. So this becomes your irrational number. And the way to write off an irrational number is that you will always have to round it off. If you want to round this off, it would be 3.413. Okay. Or you could say it would be 3.4125 6. If the number after the number is more than 5, you just add 1 to the previous number. So, what is a third? A third is the square root of a non square number. So, if inside the square root the number is a square, it can be simplified. So, that will not become an irrational number. That will become a rational number, which is not a third. So now here we come up to the concept of surds. So what is surds? Surds is square root of a non-square number. And when you find out the square root of that number on your calculator, the decimals would repeat forever without any pattern. If I sum up over here, what is a rational number and what is an irrational number? Rational number would be your integers, a fraction, or any number that has limited number of decimal places and it can be written as a fraction. But irrational numbers, they continue forever and you always have to round it off. Now we continue with surds. What is surds and how to simplify surds? When I talk about surds, the first thing I need to know about surds is a surd is an irrational root, or I could say it is a root. It is an irrational root of a rational number. Can you give me examples of surds? What could be the examples of surd? So when I say root 5, the number inside is a non-square number, so it is a surd. Okay. Another example is root 40. The number inside. Which number is this? This is a non-square number. So if it is a non-square number, it is a surd. If I say root 27, is 27 a square number or a non-square number? 27 is a non-square number, so it is a surd. It is a non-square number, so it is a surd. If I talk about root of 9, now here you have to be careful. 9 is a square number. It is 3 square is 9. So this becomes root of 3 square. So the square and the root, they cancel. So 3 becomes a rational number. A thing you have to note over here very clearly is that the third is an irrational number. It is an irrational root of a rational number. And inside the root, the number inside the root should be a non-square number. Let's try to find out the decimals of these numbers. Okay, if I say root of You can see the calculator. If I say root of 5, what is this equal to? It is equal to 2.236. See on the calculator towards your left. 067. So this is continuing, recurring. The decimals is not stopping. There is no pattern of decimal, it is a third. If I say root of 40, so this is equal to what? 6.324555320. If I say root of 27, so this is equal to 5.196152. The decimals are continuing forever. There is no repetition, there is no pattern of this decimal. So it is a third. Okay, so you should know that surds are irrational numbers. The decimal continues forever and it continues without any pattern, and there is no way to write this number other than rounding it off. But it should be a root of a non-square number. And for that, you should know what are square numbers. Now, what we need to learn over here is how to simplify surds. This is what we are learning. So, we are going to learn how to simplify surds. So, say for example, you have two numbers, irrational numbers. You have root 3 into root 5. This multiplication of surds, that is root a into root b, it is exactly the same as root of 3 into 5. Okay, or it is exactly the same as root of 15. Okay, 3 times 5 or root of 15. If I say I have root of 7 into root of 15, okay, this is exactly the same as 7 into 15. Root of 7 into 15. So it is exactly the same as root of 105. So when you want to simplify surds, okay, when you want to simplify surds, you need to know the factors of it. Say for example, I have root 40. Okay, this root 40 I can rewrite as a product of any of its factor pairs. So I can rewrite it as a product of any of its factor pairs. So what are factor pairs of 40? I would say root 40 is equal to root 1 into root 40, because 1 and 40 is the factor of 40. Now if I say 40 divided by 2, so 2 times 20 is also 40, the factor pair of 40. What else does 40 go into? 40 goes into 5. 5 times what? 40 divided by 5. I can check. 5 times 8 gives me 14. Or I could say 4 times 10 gives me 14. If I want to simplify surds, the way you should do it is you should rewrite it as a product of its factor pairs. The reason why I rewrite it as product of factor pairs is that I might get one option where a factor pair would be a square number. So if you see the fourth one, 4 into 40, this is a square. 4 is a square. So I will not take this option, not this, not this. Root of 4 can be written as root of 2 square into root of 10. The square and root would go away, and it could be written as root 40 can be written as 2 root 10. So when I am simplifying surds, I write it as a pair of its factor pairs. After I write the factor pairs, I would see which factor pair is a root of a perfect square, and then I would simplify that part. Let's give you one more example. You can pause the video and then do it. One thing you have to note over here is that this rule works only when you're multiplying or dividing. That means 40 can be written, it can be split up into 1 times 40, 2 times 20, 5 times 8, 4 times 10. Or it could be written as root of 80 divided by root of 2. If you see 80 divided by 2, it gives you 40. Okay, it can be written as 80 divided by 2. But you should remember this rule does not apply. Very, very, very important. It does not apply for addition and subtraction. So if I say this does not apply for addition and subtraction, that means you cannot say root 30 plus root 10 is equal to root 40. This is a common mistake that the kids do. But this rule does not apply for addition and subtraction. Like you have root 60 minus root 20 is equal to root 40. This rule will not apply. This rule only applies when you're multiplying using factor pairs or you are dividing it. You can take this example over here. You can pause the video and try to solve it. Simplify root of 27, root of 200, and root of 48. You can pause the video, try to solve it, and then you can come back and check. You will use factor pairs to see which factor pair you want to use. So 1 time 27 is 27. 27 does not go in the table of 2. So I will do 27 divided by 27 divided by 3, 9. So 3 times 9 is going to give me 27. Now if you see over here, 9 is the root of a perfect square. So root of 9 is nothing but it is 3. So instead of 9, I can write 3 and root 3. So it is written as 3 root 3 and it is simplified. You try over here, try the factor pairs of 200. I know 200 is root 1 into root 200 or 2 times 100 gives me 200. Now I can use this. I know 100 is a perfect square or it is a square number. So root of 100 is nothing but it is 10. So 10 times root 2 is simplification of this surd. Now if I take root 48, I want the factor pairs of 48. So I know factor pairs of 48 is root 1 into root 48, root 2 into, check, 48 divided by 2, 24. Root 24. Is any one a square number inside the root? Nothing. Let's try 3. Root 3 into 48 divided by 3. So root 3 into root 16. 16 is a square number. Okay. So I would check root of 16 is what? Root of 16 is 4. So instead of 16, I can write 4. So it would be 4 root 3. I have simplified this surd. Now you need to simplify this surd. Root 500. Root 500, find the factor pairs. What will you find? Factor pairs. If I am supposed to find the factor pairs, that means root of 5 into root of 100. This comes clearly into my mind that 5 times 100 gives me 500. Root of 100 is clearly 10, and this would be root 5. So if I am simplifying this surd, it would be 10 root 5. So simplification of 500 is 10 root 5. Now the B part, show that root of 500 plus 3 root 5 minus root of 80 can be written in the form of k root 5. What I would do is I would try to simplify the surds, seeing that I get something as common, and here they have given it root 5. Root of 500 can be written as root of 5 into root of 100, because 5 times 100 gives me 500. Plus 3 root 5, I will write as it is. Now let's find the factor pair of 80. Okay, how will I find it? So if I say 80 divided by 5, it's 16. So that means 16 times 5 is going to give me 80. So it will be written as, this 80 will be written as root of 16 into root of 5. This can be done only in case of multiplication and division. Now if I see root 5 is common everywhere. So I will bring the root 5 out. So this becomes root of 100 plus 3 minus root of 16. The root 5 has come out. Now I will find the answers. Root of 100 is nothing but it is 10 plus 3 root of 16. If you don't know, you have a calculator. Root of 16 is nothing but it is 4. And then I will do 10 plus 3 minus 4. This gives me 9. So this becomes 9 root 5. So I'm writing it in the form of k root 5. So my k is nothing but it is 9. So I have simplified the surd. Now I have a question over here. Show that root 28 minus root of 175 over 9 plus root 2 over root 2 over 9 can be written in the form of 1 by a b root 7 plus c. You don't need to get panic. You just have to simplify the surd. And they've given you a hint over here. They want root 7. So I'll first write the question root 28 minus root of 175 over 9 plus root of 2 over 9. Okay, let's see this. 28, break it into factor pairs of 28. So 28 divided by 7. That means 7 fours are 28, and this I will put in root. You try to break it in root 7. Now This I will break it. Root of 175. I know 175 clearly goes in the table of 5, but I will try to see if it goes in the table of 7. So 175 divided by 7 is 25. So this can be written as root of 25 into 7, and this root 9. Root 9, 9 is a perfect square, so root 9 can be written as 3. You see the calculator besides. Now you have the third term, that is plus root 2. Now if you see, I will break this root 2 over root 9. When I solve just this part, root 2 into root 2 gives me 2 and root of 9 is 3. If you want, you can check root 2 into root 2 gives us 2 and root of 9 is 3. Now I have the other part, that is this part, root 7. Root of 4 is nothing but it is 2 minus, break this factor pair, root of 25 into root of 7 over 3. This plus sign remains as it is. So this will become 2 root 7. Root of 25 is nothing but it is 5. So this becomes 5 root 7 over 3. And this is plus 2 by 3. Now I want all the terms to have 3 in the denominator. So what will I do? For this term, I will multiply the numerator and the denominator by 3. So I will do 2 root 7 into 3 upon 3, and these terms I'll copy as it is. Okay, so this becomes 2 into 3 makes it 6 root 7 over 3, and these terms I copy as it is, minus 5 root 7 plus 2. Now the denominator is the same, so I will write it upon 3. This will become, numerator will be 6 root 7 minus 5 root 7 plus 2. Okay. This has root 7 and root 7, so it can be clubbed together. I will remove root 7 and this will be 6 minus 5 plus 2 by 3. So this becomes root 7. 6 minus 5 is nothing but it is 1. So it becomes root 7 plus 2 by 3. So this could be your answer, but I want it in the form of 1 by a b root 7 plus c. What I can do is, I can remove this 1 by 3 outside. So it becomes 1 by 3. In the bracket, you will have root 7 plus 2. So if I say this is 1 by a, b is 1, and c is 2, and root 7 is there. So your main answer is 1 by 3 root 7 plus 2. And I have expressed it in the form of 1 by a b root 7 plus 2. You can pause and try to do it yourself. Now what you have to do is, you do not have to use the calculator, but you need to try exercise 1E, where you're going to try to simplify the surds. Okay, and then you will expand and simplify if possible. I will make another video where I will solve these sums for you. Okay, so this is all about surds and simplifying it. In the next video, I will solve this exercise, and the next video after that, we will study about rationalizing the surds.